mechanically determine what it is that you want to be taking when you see this kind of.
But now,
wait,
like I don't understand. Like in terms of stop losses,
your stop loss and your this.
Wait till you like me. Any trade with 7-8 pips, I will know my trade. Like I know you like to take them because
So
me I
hello,
always dey flip account. Like even
good
today
evening,
sef,
guys. We
I
are
even
live
flip too.
already.
So like me I dey always dey
So,
I go just reach $3, $4, collect 1:5.
so
So wetin I dey do be say this trade now, if I see am say e don reach like 8 pips, I no dey take this trade. I go dey look my system like this, look am. Market must give me
Okay.
wetin I dey
Good evening,
want
guys.
for
In our
15 minutes.
welcome to
And give
today's
me for 1
class
minute
of
before I
how
will
to
do
read on
that.
Solana. Today's day 16.
Mm.
So today we are going to be going through
Yes.
creating the token program token.ts. Then the next thing is the token metadata, which was what we did in our last class actually, of which I pushed it to GitHub so that we can go on and practice. Actually, the first file or the first function to create the token mint. So the token mint is actually the first deploy on Solana or on a blockchain. If you are going to create a token on a blockchain, in this context, it is Solana. So the first thing we create a token mint. This is the function we wrote. First, we imported the necessary things. We imported the create mint from the Solana SPL token, then the .env to hold our env key there, and also our private key.
Let's say you are no. I will come now. Maybe you put me through now. You dey run cloud?
Nah, just all this kind. Yes, MongoDB and all this kind.
When you dey use
I don't think this will be able to take you through your class because me, I can't sleep without phone. And this thing is already.
Okay, I'll just be doing like 10 minutes interval if it reduces to like 10%.
Me, as I'm telling you, is now this thing is getting like 3 bars. You plug this thing into the moment it's at 3 bars, it takes probably like 2 hours max before it switches on. So that's the only I'm saying now. Because now you know we are fair and again the uniforms it doesn't charge like so that's why I'm going to you're going to because I don't want it to switch on. Because now I can't sleep as I eat.
That's fine. Yeah.
So that's why I'm not.
I'll just try and manage as much as possible.
This game doesn't have more than 2 hours battery.
Solana SPL token library. Then the env file which we store our secret key, our code, our public to anyone that have access to the program there. So that's why we have to store it in a separate file which is .env, and that is basically the work of env files. So that's why we imported the .env /config. So the next environment is just this env stands for environment. So it is getting the key pair from Net Explorer link, which generates the link we can use to view our token program and also the transaction details in the Solana network. The Solana Explorer rather. Then the next thing we go on to import the connection, public key, transaction signer, cluster API URL from the Solana web3.js. So this connection is the function that actually establishes the connection between our code or our program here with the Solana network. So then our public key is going to, when we view our code, when we view our token program on the Solana Explorer, which we imported the Explorer link here, this public key, what it does is we get our it's actually it generates our address, the public key and all of that. So transactions, so basically anything we do on the Solana network is a transaction. So This transaction is the function that initializes the transaction. The transaction we initiate in order to query the Solana network. So we do that in form of a transaction. Then the signer. The signer is actually a public key that initiates or creates the token which we do, which we are making or creating. Then the cluster API URL. This cluster API URL is just the Solana network. We have our devnet, we have the testnet, mainnet, beta. Here's where we use it here. So get key pair from environment, secret key. So this secret key is the very used to store these secret keys. So I'm only exposing this secret key for this tutorial because I'm not going to use TS file, which we did before, where we use this to generate a key pair. So that is it. So do a console log, show to print out what we've done, what we have established here. So we just say connected. So let me change the message and say connection established. Yeah. Then we are going to see our public key. We will see our public key first. Then um is the constant that or variable that will hold the token mint. That the first thing we do is to create a token mint, then we create a token mint account next, then we mint the token. After minting the token, then we can go on to transfer the token, and after transferring the token you can then do a burn. You can burn the tokens. So it's going to await a response from the create mint function, this create mint function here. So it's going to take in our connection which we made here. The next thing is the user, which is the key pair, which is my key pair actually that I used to initiate this transaction. Then if you come here, you see all the things. You can see connection, which is the connection. Then the next thing is the signer, the payer, or which is a signer type. So this payer is me using my key pair, which is that's why I put the user here as the or function argument rather. Then there is mint authority and freeze authority. So this mint authority is my public key, then the freeze authority is still my public key. So I'm the one that has the right to mint this token, and also I can freeze the token. Anybody that has token, I can actually freeze it. And just like the way you have USDC, the person with the mint authority and freeze authority can actually freeze every USDC that everybody is holding, and your USDC is freezed. You can't use it for anything again. Then the next thing, this 2 is called a decimal. If you come here, you see connection, payer, mint authority, freeze authority, which is also a public key, then decimals. You have decimals. So all these other ones are not. See, token mint is now create control. I'll save the file, then come to my terminal to run it. So let me cd into the cryptography. So I'm now in my cryptography. So I will run the file now, npx esrun token.ts. So now it has here's the explorer link for the token.ts. So I'll copy the link, then go to my browser and paste it. Let me paste on my browser now. So here we go now. So um this is the token mint we have made here. So this is the address. Token mint address, current supply is 0 for the current supply. Then the mint authority, this is the freeze authority which we made here. So you can see, because we use the same public key for both the mint and freeze authority, they are the same address. That's why you can see them here. Then the decimal here is 2. Why we use 2 for decimal is because we just do that because most of the tokens that are being created, especially on Solana, they use 2 as the decimal. So you can see transaction history. So this is the transaction signature. As we discussed in our previous classes, every transaction generates a signature which can be used to access that transaction in the blockchain. So this is the transaction signature at block this number in the blockchain there, the age. It's showing 5 hours ago because this time is actually a UTC um, time. It's UTC timestamp. This is the date, 16th January 2024 at this time. So this is the UTC time, and this is today's date, 16th January 2024. Result is success. So that is that about creating a token mint. Then we now go on to create after creating a token, or rather when you want to create a token, after creating the token mint, the next thing to do is to create the token metadata. The token metadata is the next thing to create. So here is the metadata. So it's in the metadata you specify the name and the rest stuff and the other details of the token, which is the data of the token, which is actually a metadata. So here we go. We've done this before. I'm just doing like a brief revision for the benefit of those that just joined, or maybe you are not able to get up to speed on time. So here, first I'm importing the .env config because I will still be referencing to the .env file. So see, I'm not going to be importing create mint here because I've created the mint already. I've created the token mint already. So in the metadata here, this um, file is because it's basically to write the metadata of the token, to write a function to create the metadata for the token. So this is importing .env, then get key pair from environment, get explorer link because we are going to be generating an explorer link for it to view on the Solana Explorer from Solana developers helpers. Then the next thing to import is the connection, public key, transaction, cluster API URL, send and confirm transaction from Solana Web3.js. So this send and confirm transaction, the work it does is when the um it's actually the function behind the instruction you give in a transaction to query the Solana network. Maybe you want to await a response or something. So you initiate a transaction, then in the transaction, you write instruction inside the transaction, which is the form that transaction is going to take. That you are specifying what exactly the transaction is going to do. So this send and confirm transaction is the function behind that. So you send the transaction and then you confirm the transaction based on the instruction you have imputed in that particular transaction function. So that's what this send and confirm transaction does. So the next thing we do is create create metadata account v3 instruction. So this one, it's just actually to create an account. Is the function that creates an account from the, basically the metadata we are using Metaplex, the Metaplex program in Solana. So this creates metadata account instruction. Um, what it does is that it just basically creates an account for the token mint we created, and which the token mint account, which is going to basically store the metadata we are going to be writing for the token. So next, we initiate a connection, and a connection, new connection, cluster API URL, devnet. We set it to devnet also, which I explained earlier. Then the next thing, create a const user get key pair from environment secret key, right? So then we console log, we say connected, and the let me say and our public key is user dot public key, then dot two base 58. So this dot two base 58 is just to make it more readable identity in the Solana from Metaplex. So I think my screen has gone. Let me reshare my screen. All right. So yeah, I think my screen is back. So I'll go back. So this address here in the token mint, this address is the address that is meant to be in this token mint account. So because I have written this code before and I've gotten an address already, I got the address to be this 2J, 3J, blah blah blah. So that I'm not going to be copying and pasting this one into my metadata file, because each time you refresh this thing, the address changes. Um, let it refresh. So I think this is another address, or each time you run the code, each time you run this token .ts, if you run it again, you will get another address. So it is the address of the previous code I ran in the class that I am using for this our metadata here. So I don't know if you get that or if you understand that. So that is that about this one here. So you can see name a string, symbol a string. Let me share it again. Network. So as I was saying, these are the screen has gone again. Okay, the screen is back now. So here we go. Names Super Team Kano Devs 2024. So we have name, symbol, URI, a form in form of a link, seller free basis points, creators, collection, and uses. Actually, for the symbol being SKDC, so meaning Solana Kano Developers. Solana Kano Developers, Super Team rather, Super Team Kano Developers coin. Yeah, I just named it that. So the next thing actually is we declare a const for the metadata PDA. So we named it const metadata PDA and bump because of some eh, or some types we are going to be passing in and convert PDA and bump to public key dot find program address and address of a profile. We do a buffer dot from metadata. Then we is one element of this object. So buffer dot from metadata token metadata program ID dot to buffer. So excuse me. Yeah, let me confirm. Okay, Farid is here. I believe the screen has shown now. So Farid, please confirm for me. Okay, thank you, Farid. Message retracted. So next is the token mint account. So the token mint account is this public key, which is supposed to be the address we generated from this transaction, our token mint transaction. So why it's not exactly the same with the address here is because this is the address I generated previously when I ran code after our last class. So that's how we got here. So token mint dot to buffer. Then the next is the token metadata program ID, which is this token metadata program ID we get from Metaplex in the Solana network. So const metadata PDA is going to reference the first element of this constant, or yes, this constant, the first element. So the first element of this array is the buffer dot from metadata. So that's why we pass in a zero here. And we all know in programming, counting starts from zero and not from one. From zero, one, two, and like that. So the next thing, we run a check to see if our metadata account already exists. Because actually, you see all of these things, if addresses, where you place addresses, if they are not well placed, like where you are supposed to place the metadata program ID, you put maybe your own address or the recipient's address there, or you just misplace addresses, you get errors. Now, once if you run the code, if you run this metadata .ts file, and then you run it again, once you the first run you run it, it is already existing on the network. So most of the time when you run it again for the second time, you are going to get an error. So what this error will tell you is that it will give you error indicating that okay, this guy you are running is already existing and it cannot create another account to hold your token mint program, which you cannot create another account on that token mint you initially um created. It cannot create another account to accommodate the metadata program you wrote again. So it's going to throw you an error. So I based on what I researched on and some things I did, I believe now, yeah, it's good to like write code or write functions that will catch some of these errors. So that's why I commented some things here that I believe will be helpful for our understanding. So to check if the metadata account already exists, I'll say I did a const here, say const metadata account information or metadata account info equal to await, it will await a connection dot get info metadata PDA. This metadata PDA, it will check now, it will await the connection because it's awaiting a request actually. So it is awaiting a request, and that request is the account information that this metadata PDA is going to generate. This metadata PDA has a different function, which is to create the metadata PDA of the metadata we are writing in this program. But to check if that account already exists, we now create this metadata to await the account information from the network before it actually goes into work. So if it already exists, now we now go on to write an if statement to handle the possible errors or possible outcomes when we query the network for information, that's checking whether it exists or not. That's so that we can steadily run this thing and get different outputs and get correct outputs when we run our code files. So I said if metadata account information is equal to, that's if it is null, this triple equal to equals, that's meaning it is equal to null. Single equal means you are assigning a variable. Double equal is a numerical equality sign. Then triple equal is both is a type. You are comparing types now. So if the type is null, transaction now. So what I'm if it doesn't exist, create another one. So that's why I declared a new transaction here. I created the variable transaction, new transaction. So in the initialization of this transaction can happen anywhere outside the code. But because I want to like handle everything together and catch possible errors, that's why I'm putting it inside this if statement. So const transaction equal to new transaction, um creating a new transaction. So then I go on to say const create metadata account instruction. So this is creating a metadata account instruction. So the instruction that the metadata account is going to pass or is going to deliver into the Solana network. So I'm using this function now, create metadata account v3 instruction, which is what I imported up here. I imported it here. Create metadata account. This v3 is a version 3. So this function has several versions. It has version 1, 2, and 3. So this version 3 is the happens to be the So what it does is create a metadata account instruction. So the V3 stands for version 3. So it takes in um objects. So inside this object, it takes in an object of two um elements, and you know elements in an object are key value pairs. So, or rather, these two objects are objects on their own. So the first object takes in one, two, three, four, five, five elements, and these elements are key value pairs. So the first one is metadata, which is the key. Mint, we have the mint authority, the payer, and the update authority. So the metadata key, the value is the metadata PDA, which we made here. Is the metadata PDA which we made here. Then the mint is this token mint account we have created. Then the mint authority is the user.public key, which is my own public key now. Then there is the payer. The payer is still my public key. Then we have update authority. The update authority is still my public key because I will be the one that will be doing everything about the token. I will be the one to mint the token, meaning I have the mint authority. Then the payer, which is the user, which is still me. Then update authority. I still my public key is still the freeze authority, and I'm still the one that is going to do like everything doable with this token. So create metadata account arguments. So it's the args here. So it's also version 3. So collection details none, data. So the data I pass in is actually my metadata. So my metadata is this constant which I use to create all the metadata: name, symbol, URI, seller fee, basis points, creators, collections, and uses. So that is what I passed in here. Then the next thing is mutable, which is set to true. Then the transaction I created initially. So I'm going to add the transaction. So here, watch what happened here. I created transaction inside this, I made it inside this if statement. That so this thing will happen if the transaction doesn't exist. That's if I run it for the second time. If the one I run previously, or sorry, if I run it for the first time, the transaction will go on to exist. If I run it for the second time, I will get an error. The error will indicate that it has been run and it is already existing. So it is now going to generate me my Explorer link. But I need the Explorer link regardless of how many times I run the program. So this transaction now that I initialized here, it is now time to put the transaction into work. So transaction.add, meaning now this creates metadata account instruction. I am adding it to this transaction function I made here. So this is a function. So I have added it. I have now instructed the transaction that this is what you are going to, all of this that I put into this constant, it is what you are going to do for my transaction. So now, after the transaction, after I've specified what is going to happen in the transaction, then I will create I will create a constant for the transaction signature. So it's just like I said, every transaction generates a signature. Every transaction you make on the Solana network generates a transaction signature. So this transaction signature is going to await await send and confirm transaction. This send and confirm transaction function, which I imported up there. So it goes like this. I send a transaction to the network, or let me say, I query the network. What I do to the network, to the Solana network, is a transaction, and the transaction contains this information that I've just this create metadata account instruction, and it has gone. Now, that transaction has to be confirmed. Once the transaction is confirmed, it is going to generate a transaction signature. That transaction signature is what can be used to access that my transaction that I made on the Solana blockchain. So that is why I'm using await function here, because it is going to wait. This transaction signature constant here, it is bound to wait for the transaction to be confirmed. Then it will now generate the transaction signature for my transaction. So that's why we use await. Then this function send and confirm transaction. Then we pass in the necessary things, which is connection, then transaction, then let me pop up now. Then this user array we made up there. Or sorry, a user which um which is supposed to be, let me open it. It is supposed to be my peer that I made there. So connection first, it connects to the network, then it makes the transaction, then it's also passing the user or the author of the transaction. Then that transaction signature can can be generated. Then next is transaction link. So this transaction link happens to be the Explorer link that we are going to view. So my screen is off again. Let me stop sharing. So let me check. Please confirm for me for my screen. Confirm my screen for me, please. Oh, so please confirm my screen for me as I'm checking also. So all right, yeah. So the screen is back. So so const transaction link is the get explorer link transaction. So this get explorer link, I will say the const to generate the explorer link. So we are using the function then. Ah, so let me wait for this screen to come up. All right. So it's going to be a type of transaction. Then it will include the transaction signature, and finally the cluster API URL, which is the we are going to do. But else link. So I'll go on now. Battery is low. I'll paste this guy here. So it's loading. So here we go. So this is the token mint address, then token program ID. These are information, update authority, and the rest of the data. So these one are just previous in transactions that have been going on. So this is balance in Sol. This is supposed to be the no, it's not the transaction fee. So when we come tomorrow, we are going to go through all the instructions here. Then we'll create a token account, token mint, and then we'll go into transferring of the token actually. So guys, see you guys tomorrow. This was actually a short class because I meant it to be a revision class for the token program based on for the benefit of those of us that newly joined and have not been able to keep up to speed. So thank you guys. See you guys tomorrow actually. Yeah.